Welcome, ladies and gentlemen. Here I go again. Hello, welcome once again here in the forum of Hydrant and Fuel Cells Europe, here on Hannovermesse 2022. We have a lot of nice presentations here, interviews on stage, but now we have a panel discussion, and the panel discussion is called Fuel Cells for Mobility, who is advancing the technology in Europe. And for this discussion, I would like to welcome right next to me Dr. Stefan Dwenger. He is Director Product Engineering from Ekpo Fuel Cell Technologies. Welcome here, Dr. Dwenger. I would like to welcome Josef Macherhammer. He is Product Manager Fuel Cells at AVL List in Austria. And also a warm welcome to Björn Noack. He is Director Sustainable Mobility Strategy, Robert Bosch GmbH. And opposite of me is Bart Biebuyck. He is Executive Director of the Clean Hydrant Partnership, formerly known as the Fuel Cell and Hydrogen Joint Undertaking, but that was formerly, now it's the Clean Hydrant Partnership. Very well, and you're always invited to ask questions. Whenever you have a question, give me a sign. I will look around from time to time, and if you give me a sign, I will come with a microphone right to you so you can ask your question. Dr. Dwenger, let's talk about Ekpo Fuel Cell Technologies. It's a joint venture of Elring-Klinger, that's the Ek, and right. The Po is Plastic Omnium. Correct. So that's a combination. It's in the field of development and large-scale production of fuel cell stacks for CO2 neutral mobility. What strengths do the two partners bring into this partnership?
Yeah, so Elring-Klinger is quite known in fuel cell development since 20 years, and I think this part was transferred to the Ekpo. Yeah. On the other hand, PO is a well-known tier 1 supplier as well, globally acting, brought in capital as well as the know-how to do the industrialization of the thing. So we're currently working on, I would say, large-scale production of fuel cell stacks, and I think this combination helps to, I would say, make this happen. Yeah.
I know Plastic Omnium is a big automotive supplier, and times are pretty hard for automotive supplier at the moment. You can all, sing a song about that, to say it in German. It's pretty tough, but they already invested in fuel cells since 2015. That's quite a long time already.
Yes, yeah, absolutely, it's a long time. So PO is concentrating on the system as well as the vessel business, on clean hydrogen business there, and Elring-Klinger brought in their expertise in stacks. Since 20 years working on that, coming from stamping, forming, plastic injection molding, I would say bringing this technology to do stacks, to do bipolar plates in metal as well, plastic components for the media supply unit. So I would say just a transfer from old classical business into the new mobility like fuel cells, and this is why I would say this combination fits quite well. Yeah.
And the stacks that you're providing the OEMs with are used primarily in commercial vehicles. So we say in buses, at sea and rail. What about passenger cars? Are you thinking about passenger cars as well?
There are applications ongoing in passenger cars, mainly as a range extender. Also, there's a strong focus in China as one big market. We see a big trend to, I would say, heavy-duty applications. We see as well marine, rail as it's quite decisive because I would say the cost of ownership drives the thing, and I would say heavy duty is one of the, I would say, key markets which will come. I'm quite sure about it.
Mr. Noack, Bosch is a leading automotive supplier here in Germany, based here in Germany, but worldwide leading. Well, they're tough times at the moment, aren't they?
Yes, indeed. So we have a lot of supply chain issues, we have market interruptions, so it's not an easy time. For us as Bosch, we are a very diverse company, so we do not have only automotive, we have also other sectors that we supply to, so we can somehow manage. But of course, we are also very much concerned about the tier 2s, tier 3s, all the smaller and medium-sized companies that are very much important for us to produce our products and to keep our industry running. We should be even more worried about them and open for them a door also for the things that come after combustion engine. For them, it's really hard to find the transformation path.
But is that the role of the supplier to prepare something for the OEMs that they're just in time when they need it? Shouldn't the OEMs do themselves something?
Definitely, and I think they are. If we look on a global scale, we see also when we talk about fuel cell technologies, we see a lot of OEMs moving fast into this business. Probably in Germany and Europe, we are still stuck in the discussion how to bring hydrogen to market, what is the green hydrogen that would qualify for transport, how much quantity should we put to transport sector at all. Then we need to talk about fueling stations. We have other markets where this is much easier. Take US with a very renowned manufacturer that will go to market there soon, and also take a look to China. In China, since this year, we have 70 trucks on Bosch fuel cell technology on the roads already, and we will hit 500 this year. So in other markets, it's developing quite well, though it's not the suppliers who have to push this technology to the OEMs.
Maybe you don't have the capacities in the future for the European market because you're so busy in China, are you?
Definitely, we need to look at the capacity situation as well. So not again in the Bosch premises, so we know how to produce them, we can scale them, but we would also need to start the discussions on about raw materials. So also in the fuel cell technology, we have certain raw materials where we still need to make sure that we can meet with the demand, and that in time we erect also a system to take them back after the useful life. So we need to come into a circular economy there. Another topic where the discussions in Europe are still very premature compared to other markets.
Mr. Macherhammer, Avialist is not a supplier like Klinger or Plastic Omnium or Bosch we have here on stage, but it's an engineering company for the development, simulation and testing in the automotive sector. Why did AVL decide to build up fuel cell know-how and competences already 20 years ago?
Yeah, it's a very good question, but I think already a long time, 20 years ago, AVL decided, okay, something needs to happen to reduce the CO2 footprint, which is essential for our society. And back then it seemed quite logical to go into new technologies, because obviously we were focusing and still focusing on the combustion engine, but we were thinking what comes next. And 20 years ago we decided we feel fuel cell will power future propulsion systems and might be the mainstream solution for a lot of applications.
But 20 years of investment without return of investment,
yeah.
right?
Yeah, you are absolutely right. That's the lucky part of AVL, is it's still a family-owned business, and Professor List still strongly believes, and now he is right, I have to say. Yeah.
No, it's correct indeed. Well, your competence is not limited to automotive applications. You also have knowledge in power and heat generation with SOFC and hydrogen e-fuel production with SOEC technology. Are you still an automotive engineering company?
Yeah, we are still, frankly speaking. Of course, our main business is automotive, but we have seen the strong. Okay, first of all, we have 3 technology pillars. So it's the PEM for mobility, the SOFC for power generation and heat generation. Maybe for big ships it might be an option as well. And very similar to the SOFC is the SOEC, the electrolysis technology, where we currently see a very big demand worldwide to cover the capacities to get enough hydrogen produced in the near future.
Okay, you don't mind if it's automotive or not. You just
absolutely right. Yeah.
Okay. Bart, let's talk about the Clean Hydrogen Partnership. It's a public-private partnership. The European Union has initiated to contribute to EU Green Deal and hydrogen strategy. What are your main activities? Please explain that to us.
Okay, well, we are first, as you said, a public-private partnership, and we are funding research and innovation projects. And then depending on the stage of your project, we can fund even up to 100%. We have done that already since 2008. I mean, we have supported now 287 projects, and I think you're all received some of the funding as well from our program here. We have spent more than 2 billion euro, and so together, 1 billion from the Commission, 1 billion from the private members. And so last December we started the new partnership, because the Commission wants to go faster. I mean, part of the hydrogen strategy, of course, the research agenda that we need to fulfill. So we will put another 1 billion euro as public money into the research and innovation, and then of course the industry another 1 billion euro. And last week we were very happy with the Repower EU, because Repower EU announced that we will get another 200 million euro extra in our program, so in order to speed up to get rid of the Russian gas as fast as possible. But then looking to the contents of the program itself, so we have 3 main pillars. Is the hydrogen production, mainly electrolyzers, then hydrogen distribution and storage. I think this is new for us, because in the past we focused a lot on the production, focused less on the end use, and now we have to connect the dots. And that's why we need the infrastructure now, and that's very important. And finally, we are also working on end use applications. That's the third main pillar. And here I want to be very clear, fuel cells is still a big part of our program. We actually, if you would look to the call that we launched on the 1st of March, 300 million euro, which is, by the way, the biggest call ever in the history of Europe for hydrogen, dedicated for hydrogen. It has a lot of funding for fuel cells in that. So don't misunderstand, even we call clean hydrogen, we still do fuel cells.
Is that part still research programs, developing programs, and is it still needed for this technology?
Definitely. I mean, of course, we're shifting a little bit. I mean, if you look, we have funded a lot of hydrogen refueling stations for cars. We have funded a lot the vehicles itself. But now we have to go, for example, to go to the whole other extreme, aviation. So in our call, there's a lot of money now put available for designing a fuel cell for aviation. So we have to do a lot of research still. And then secondly, we need to still get cost reduction. I mean, the materials was one issue. Maybe we need to change materials. We need to get down the cost of a fuel cell. It's too expensive still. So there's a lot of work still to be done for us.
But I remember a fuel cell and hydrogen joint undertaking project called Volume Manufacturing of PEM Fuel Cell Stacks in Transportation and Inline Quality Assurance, short volumetric. That ended already 3 years ago. Should we renew it again?
I think we could look at, I mean, supporting the mass manufacturing is also part of our mission. We have to do that, and we have to scale up. I mean, this project that you mentioned, volumetric and so on, I mean, it was very successful. I mean, they start producing now, I mean, tens of thousands of fuel cell stacks. It's possible with the manufacturing lines that we have built or supported, I would say. But of course, it's not enough. We have to go to millions, I mean, 100,000s of production. So for sure, we need to do more. We could imagine that we need to do research projects for quality control, because now a lot of quality control happens manually. So how do we do that really on mass production to make sure that we have always the same quality? These are things that we need to look at.
Dr. Dwenger, how important are these initiatives on the European scale for you, for Ekpo? You're a young company, but do you profit from it, or does it take too much effort to get the money? You better do it on your own.
No, absolutely, it makes sense to go for that. Yeah, so fully agree with what Bart was saying, especially volumetric showed that how to proceed in the future, and I think this is still needed because what we're facing today. So we have the capabilities to do 10,000 stacks per year, which is a lot. I think this is unique. You can see it at the booth, how we do it. But I think there's still a way to go. It's a big difference if you go for 10,000 or if you go for 1 million. So I'm an automotive guy. I know what this means. So. Therefore, I think this is clearly needed and also requested from the companies to do that, because there's a long way to go, especially for the suppliers, as Mr. Novak said. Yeah, so a lot of things are ongoing, but they're needed still. Yeah, definitely.
Mr. Novak, let's talk about your fuel cell stacks. You have a partnership with PowerCell Sweden for these fuel cell stacks. Where do you see them in the end? Like Dr. Dwenger in commercial vehicles?
That's at least our clear focus for our R&D. So I think he talked about TCO already, total cost of ownership. So we still have to see that fuel cell powertrains are very expensive still. We need to bring down the cost. So we need to make sure that we put them into applications where the customers run them continuously and then can really get a payback of the investment, initial investment. That is why we focus on the heavy duty transport, plus on long distances, long haul trucking. Because if we really want to fight climate change, we need to analyze where is the CO2 coming from. And in heavy duty, it's not coming from the regional deliveries. It's really on the long run, trans-European travels, many thousand kilometers, heavily loaded. This is where the major chunk of CO2 in heavy duty trucking comes from. And that is why this makes a lot of sense in terms of TCO and in terms of effective climate protection.
So, no, but what's interesting to me is I see all these partnerships in your business. You know, like the hydrogen tank systems. You have a partnership together with Saleri for pressure up to 700 bar. Is it because it's just too heavy to do it all alone, or it's rather to get as many people on board as possible, or to get the technology?
No, I think the easy answer is, of course, it saves us a lot of investment. But that's a very simple finding, right? So I think
You have
it's
to
more.
share the outcome at the end.
I think it's more relevant to look how can we really join the competencies that we need to really bring up excellent technical solutions, and at the end, from a technical solution, also a valuable product. And there we have in the past done very great experiences in joining in partnerships, carefully selected so that we really can bring different competencies together. Like in Salieri case, for example, they have a lot of know-how in the gas valve already. We know how to do a mass manufacturing industrialization, bringing them together, and then let's see. So that's quite a usual approach in Bosch, that we don't do everything on our own, at least in the phase where we create a new market.
Okay, yeah. Same with you. AVL List has also a partnership with Ekpo, just next to you. I guess AVL will concentrate on the vehicle integration of the stacks, right?
Yeah. I think we are working together in all areas, but you're absolutely right. Everyone sticks to the competences. So we are supporting a little bit in system engineering and also in integration. You're absolutely right.
Okay. I always ask myself, Dr. Dwenger, why do not do the big suppliers build fuel cell cars on their own if the OEMs don't do it? You know, well, there are some in Asia who do it, but why don't you go this step? You know, it's not very far. You build whole systems already.
Yeah, if you go for, I would say, starting with a stack, you have to build a system, and then you have to integrate a system in the drivetrain and into the vehicle.
That's the easy part.
Somehow, I don't agree, to be honest. I think it's good to stick on that what you know and what you can and where you're capable, and that's why I think for us, clear focus on stacks. PO is doing the system, so, and then I would say selling that to the market to find somebody to integrate it in the vehicle together with AVL, which is great. Is, I would say, the right approach. Building vehicles is, I would say, a big step. As you can see, the new OEs, there are a couple of ones fighting for that, and only a few ones will survive from my perspective. So this is really a big jump you have to take. So it's,
But Mr. Noack, it seems not quite fair in my eyes. You know, the suppliers are doing the job that OEMs should actually do. You work on the technology, you scale up, you do the cost reduction work, you do the system integration, and the car manufacturers, at least them in Germany, they do not bring the vehicles on the market, you know, or just for a very short time, like 6 months, and only for leasing. You think you should take them and say, well, you have at least to contribute to our investments we're doing?
Of course, everyone should contribute to create this market, but I would not make the statement that they do not contribute at all. So, in fact, also in your partnership, we have H2 Hall and other projects where we successfully deploy first demonstration vehicles, and that's quite a good sign and an important step. We need to get experiences out there on the fleet. I would personally feel we should now do the next step. I think in your program there's also one special chapter in to scale transnational transports, really long-haul transports. That would be the next step to qualify. We should not forget a heavy-duty truck is an investment for the guy who is operating it. So we should not play around with premature technology. We need to go in decisive steps, qualify the technology together, and then roll it out on a larger scale. Next year, one of our customers, Nikola Iveco Europe, has already announced that we will bring serious production vehicles to the market. So there are OEMs also in Germany and in Europe who are putting these trucks on the roads.
Too many announcements, you know. I want to see the cars on the market, actually. So, but there was a supplier, Schaeffler, who brought a small car to the market, the Biebuyck hybrid. You probably know. They were not very successful. Maybe also this experience takes you away from thinking about building your own fuel cell cars, or not? Are there any plans in the pipeline for Bosch?
Actually, I would almost say we have never thought about it. So in daily business, there's so much value in the discussions with OEM. As a tier 1 supplier with an OEM, it's really such a fruitful discussion that I don't think it would be smart that we now start to build a better vehicle. This is too different. So our job is to really bundle volumes and to create synergies and platforms. And that's how we contribute to the automotive value chain.
Mr. Macherhammer, is it so complicated to build the systems you have already, to build them together in one vehicle?
Yeah, I feel, I think, can you hear me? Okay, I feel Professor List tells always a great story. if of course as a joke, but he mentions, yeah, of course we could build the best Formula One car in the world, but it's much better to build 7 of the best Formula One cars in the world. So that's, I think, answers the question. So we want to develop something, we want to push technology to the next level, and we offer this technology to all of our customers. As soon as we start to mainly build our own products, we will just, of course, we will have other customers, but we will lose our foundation as AVL basically.
I have a look around. If there are any questions here from the audience, just raise your hand. I'll be right with you with a microphone. This is not the case at the moment. Bart, I would like to ask you, if you look at the market and you're looking at it since 2008, as you said, with hydrogen fuel cells, joint undertaking and now clean partnership, we have to admit that battery technology is advancing much quicker than fuel cell technology, at least in the last decade, I think. So do you think fuel cells will not make it to passenger cars, will stay in light commercial vehicles and heavy-duty trucks?
Well, I would, I would disagree with your statement that battery technology advanced much more than fuel cell technology. Maybe in volumes, you're right that maybe the volume is bigger, but the technology advancement itself, I think that the fuel cell made a lot of advancements in the past decade. I mean, today, take 5 years ago, would you ever imagine that we would be discussing today to build a fuel cell for an Airbus plane? I don't think everybody could imagine that 5 years ago. So I think the technology evolved quite a lot. So I think this is very important to say. On the other hand, fuel cells will play also a role in the passenger car segment, especially for high intensive use vehicles. What do I mean? Taxis, for example. We see the taxi fleet in Paris. They have now 100. They will go to 600, and they said that by the Olympic Games in 24 they want to have 1,600. Let's see if they will get there. But we see in our program a lot of taxi fleets, for example. Another one is the little small low commercial vehicles, the vans. If today we order something with Amazon.com or Bol.com, we want to get our package. The moment we push on the enter button, the next day it has to be there. So those people, they drive continuously. So they cannot stop and wait and charge the car for an hour, because then the customers will complain. So those kind of segments in the passenger car, they need fuel cells. So yes, batteries will probably be the majority. I have no doubt on that. But saying that passenger car would be only a battery, I think that would be a huge mistake. And then I just would like to add one more thing. Let's see what's happening in Asia, because we're talking here in Europe, but I read this weekend Great Wall in China, they announced all the luxury vehicles or the brand will be fuel cell vehicles. So let's see, because this is a huge market, and let's see how they will bring down the cost of fuel cell, and how then vis-a-vis the battery cost, what would be cheaper. And I think it's a long-term race. Maybe on a short term we see some trends now, but on a long-term race to be seen.
Well, that's interesting. If we really look to the Chinese market, Dr. Dwenger, that could be a big competitor in the end. And as we've seen in the battery development, they have the lead at the moment. Could be in the fuel cell business as well.
Yeah, it's competition, definitely. It's a competition which is progressing quite fast. But I think it helps, I would say, to improve the technology. Maybe to add one sense regarding batteries. If you just think about recycling of batteries, this is always a big question which is not solved yet at the moment. I think the fuel cell, especially if you go for metallic bike plates, as we do, for example, we can recycle that to 98%. So that's something which should be kept in mind as well, because in 10 years we talk about all the battery powered vehicles which will be there, and what happens then? Nobody can answer this by today, so therefore I think this is really needed. So I think it's not discussion battery versus fuel cell, it's more a discussion battery and fuel cell, and I think this is something we should keep in mind. But sure, China is progressing quite fast, the incentives are there, so the market is evolving quite fast.
Raw materials are very important, of course, for fuel cells as well as for batteries, as well as for the electric motors, where heavy metals in it, heavy metal earths in it. So you said recycling, but do also suppliers think about the future recycling of their products? Do you?
Yes, We do, yeah, and we are also involved in some research projects how to do recycling, like best for high, for example, just to name one of them, which is, from my perspective, crucial. Yeah, to think about during product design, product development, how you can recycle it afterwards, because otherwise, just doing something together, say in a, let's say, easy way, is not the solution. So it has to be properly engineered, and we have to do that as for design for, I would say, recycling at the end of the day. So we already think about it, and it's I would say, clear commitment from our end that we like to have zero CO2 ideally at the end of life cycle.
So, Mr. Noack, you were nodding as well. So it's important what raw materials you use for your products and how to assemble them, that they're easy to recycle.
That they're easy to recycle, and of course we need to find the recycling processes, we need to prove them, and we need to catch the right point of time to do the investment in large-scale recycling facilities. That's still probably too early, but when is the right time, we need to discuss. And I would add one more perspective, also from a supplier's point of view. It's also related not only to technology, but also to business models. So if we look about look on fuel cell applications in heavy-duty trucks, the first life is probably in the German, Middle European market. The second life makes them being registered in Eastern Europe, still on our roads. But then third life, we never know where they are running. So how do we really get access to the stacks and the raw materials? That's then also a very challenging question of business models. Who is owning those materials? Who is owning the stacks? Who can ensure that we reach the recycling quotas? If we have that recycling process, if we have the recycling assets, the investments done, that does not tell us that we really get the material back.
If it's the same system like we have with our ICEs now, we have to get them back from Nigeria or Ghana or somewhere, you know. Okay, that's going to be a problem. But the business case is an important thing you mentioned. What is the price targets for your fuel cell stacks? Can you tell me?
That's a very interesting question. I'm quite sure many of the people on the audience would like to listen.
Sure. That's why they're here.
Not joking, I think you see how many funding programs there are in place right now to cover and free fund a little bit of the price differences between a very modern Euro 60 diesel truck and a fuel cell truck. And I think we are far from having price equality between the two powertrains. So definitely we are working on reducing the cost significantly. That is the most important thing, is that we scale up production like we do in China. We need to come into mass volume in Europe. And if we reach them, I think then it's easier to talk about the next generation of fuel cell stacks and to build in further cost reductions and to bring them down. Right now, I think we simply have to realize that we do not meet with the same powertrain cost like in diesel.
I feared I don't get any number, but Dr. Dwenger, you are pretty sure that I will ask you this question again. And your former colleague Armin Dietz said something about it, and he said last year the cost per fuel cell stack will drop to 1/5. Is that still realistic?
Yeah, definitely it is. It depends where you start from, so that's why.
I think from last year's prices.
You're asking the wrong guy, so you have to ask our sales guys regarding pricing, so I'm the only engineer. No, just kidding. But at the end, it's sure it has to be compatible with a BEV or with a, we say, classical Euro 6 powertrain of today. And at the end, you can calculate it with the TCO, where you run a truck on diesel engine basis today. You can easily calculate how the fuel cell should be. Yeah. So therefore, I recommend this kind of small exercise for you. So therefore, no number from my end as well. Yeah.
Okay, let's talk about technology again. There's still some problems to be solved, fuel cells and trucks. Especially the cooling is a problem in mountain rides, and the lifetime of the stacks. Did you solve that already, or are you still working on it?
I think it would be very brave to tell that we have solved all the challenges, especially when it comes to thermal loads. So definitely there are advances in the thermal management. We can replace materials to make them more capable of high temperature loads. But yes, for time being, this would also put some limitations, and that's actually one of the largest reasons why we also look into hydrogen motors, for example. So we could also do a thermal combustion of hydrogen. This would bring hydrogen significantly earlier to our roads. It would put business models to fueling stations that are offering hydrogen, and we can immediately climb the mountains with these technologies.
Hydrogen motors are
So
easy,
we don't
definitely.
see that they are in competition. They are complementing each other. And that also allows us to step by step improve the fuel cell quality and the requirements that we can cover without the need of taking too much risk in promising now that a fuel cell truck could run in any condition that you might think of.
But I saw you nodding, and it's a funny story, isn't it? We've seen the BMW 7 like 20 years ago running with a hydrogen combustion engine, and it's coming back with Deutz and with Bosch, as I've heard, and Kia as well. Are you believing in the hydrogen combustion engine?
I believe that the hydrogen combustion engine will play an important role, especially in I would say in the transition phase, definitely, because we need to build up the infrastructure. I mentioned earlier. Now it's the time to build up, and hydrogen combustion engine will help to increase the demand for hydrogen. So people will invest in hydrogen refueling stations, will invest in pipelines. The whole logistics chain will start to be built, and I think hydrogen combustion can definitely play a very important role. Plus, in addition to that, you also have, for example, the hydrogen tanks. So a combustion engine car or truck need tanks. So also the refueling system. So you will increase the volume. Volume increase means cost reduction. So it will play a very important role.
But for you, it's a bridging technology.
It is a bridging technology because, of course, there are also disadvantages. The efficiency, clearly, go to 20%. It's still a combustion technology. Okay, you can drive in some points on the map that you can have higher efficiency and so on and so on. You can control that. But in principle, it's much less efficient. So that means that you need to bring more hydrogen in your truck for the same distance. Also, it makes some noise. So there are disadvantages, but it is a very good bridging technology that we will need to have. I have no doubt. And it's not only Bosch working on it. There are a lot of companies working on this. We will see it. But, of course, the final goal is fuel cell. No doubt on that.
Mr. Macherhammer, you're thinking about it, and you probably stopped when Bart said, well, it's not as efficient as a fuel cell. Or would you agree?
No, I think he is absolutely right, but I think the use case for a fuel cell and for a combustion engine are completely different, caused by the different efficiency profile these two applications have. I feel as soon as you have something moving which makes cooling of the system feasible in an easy way without losing a lot of efficiency, fuel cell will outperform the combustion engine. But let's assume applications which are not moving, like a tractor or construction equipment, which is stationary. There, a combustion engine will also in the future play a significant role, because cooling will drop the efficiency of a fuel cell significantly. But of course, the mainstream solution will be a fuel cell because of the efficiency increase. And the big advantage, especially when you increase power density, you can fit more fuel cell power in the same space, which will increase the efficiency even further.
But then let's talk about fuel cells who need high temperature, like SOFCs. Maybe we see them in heavy duty trucks in the future. What do you think?
Yeah, I feel also for the thought is really great, because you have the capability to not only use hydrogen, other e-fuels would be also feasible for these high temperature fuel cells, but you have two. Yeah, efficiency is great as well. Now we have the pros. Now I talk about the cons. The size is enormous. I would state about 5 to 10 times bigger than a fuel cell or combustion, as a PEM fuel cell or combustion engine. And additionally, the transient behavior is not satisfying. So switching it on and off and ramping it up and down will significantly affect the durability and also takes a while. Therefore, I don't see it coming in smaller mobility applications, also heavy-duty trucks, but it might be very feasible for marine, where you have a lot of space, where you also might need other type of fuels. Therefore, high-temperature fuel cell propulsion will be very important.
Dr. Dwenger, wouldn't it be very convincing for your customers if your mother companies would build up an own hydrogen fleet for their logistics?
That's a good question, yeah.
Same question to you, Mr. Nowak, by the way.
At the end, it's always about how to demonstrate the technology and where to demonstrate the technology. And Mr. Nowak mentioned H2 Hall, for example. So first system of PO will go now on the street. So this helps to show customers how it works, how it goes. It's, I would say, also a costly thing. So we're a Swabian company, yeah. So we take care about costs. So therefore, I think it's good to have, I would say, programs working together with customers, learn from customers, see what they need, to understand the market needs, and go there with your product and show it on the market as, I would say, real life application, not just, I would say, building some kind of artificial thing which is going on the fleet under your control. So I think real life is outside, and therefore you need the customer, and therefore we stick on that.
Robert Bosch could be a big customer for you.
Definitely, so like you phrased it, so building up an own fleet is quite attractive and very senseful. It gives a lot of sense. So that does not mean that we build the vehicles, right? But building up their own fleet, in fact, we are looking into this. We had 2 weeks back, we had a pre-event to the Hannover Fair in our plant in Hamburg. I see 2 of those makers from Hamburg witnessing us in the audience. So in Hamburg, we have installed what we call a hydrogen cycle or circle. No? So we are producing hydrogen there. We are also using it in processes, but also to run intralogistics. And in the future, we are also prepared to kickstart the first pilot project where we run trucks. So we call it then green energy for green products, so that we can truck our fuel cell products not with a diesel engine, but with a fuel cell truck.
Mr. Macherhammer, it's interesting for me to see that 2 companies represented here on stage are still managed by the founding family members. What role plays Professor Helmut List, who is 81 already, in the direction of the company towards fuel cell technology? You mentioned it in the beginning, even 20 years before, he said, well, we're going to invest in that. Is he still running for it? Does he still think it's very important?
Yeah, absolutely. It's I feel it's really impressive. He's a very visionary guy, and I feel he has proven me it for a long time now that he really knows and feels what's coming next, what needs to be done in terms of technology. Of course, not every pathway is the right one, but in general, he made a lot of great decisions in the past, and he decided 20 years ago, maybe a little bit early as mentioned, but back then he thought there must be an alternative, and fuel cell was one alternative. And he's still the driving force behind everything. So he's very much involved in everything fuel cell related and other topics as well.
And enthusiastic, Dr. Dwenger. I don't know if you ever met Laurent Burel. He's 72 and the founder of Classic Omnium. Is it that white old men drive the technology forward at the moment?
I think the situation is a little bit different at EK and PO. So PO is managed by Laurent Favre together with Madame Burel, so with his daughter. But it feels still, I would say, like an anchor. So they act like an anchor at PO, and on EK side, the family Lechler, working as an anchor investor, which helps to, I would say, calm down business also in, I would say, a tricky time. So therefore, I think this is a good situation for every company, that you don't have, I would say, stock market driven effects on the company, which lead to short-term decisions, and therefore I would say this strategic and innovative way can be pursued by that.
Bart, last word is for you. What would you resume? Is who's advancing the fuel cell technology for mobility in Europe? You think it's the OEMs or rather the suppliers?
For sure, both. They're working both a lot on them. I believe that the suppliers are pushing, for sure. They're pushing also the OEMs. But I think the role of the OEMs should not be underestimated. They are very important. I mean, for example, BMW is investing massive amount also in fuel cell development. I mean, if you see the test benches and so on, I mean, they are also, I mean, it's something you do together. It's not one or the other. But I do believe that fuel cells and hydrogen or fuel cells are important also for our suppliers, for their survival. I think that's also one of the reasons why they are pushing so hard.
Thank you very much, gentlemen. Here on stage, we're running out of time and have to keep the time. I see there's a question, but Dr. Hagen can ask it personally to you. Thanks once again for having for being here at this panel discussion. Please, audience, please give them a big hand.